If it's natural, the question is what produces this unusual abundances of elements. And together with my postdoc, Morgan McLeod, I came up with an idea that you can, in principle, produce this abundance of elements by taking a planet like the Earth and bringing it very close to the most common type of star, a dwarf star. So most of the stars are 10% of the mass of the sun. And they have roughly a size that it is 10 times smaller than the sun. So altogether, they are 100 times denser than the sun. And that means that, if you bring the Earth close to the sun, it will not tidally disrupt it. It will not destroy it by the force of gravity. However, if you bring the Earth close to the most common star, a dwarf star, it's so dense that it could, in principle, spaghettify the planet and make a stream of rocks out of it. And since those are the most common stars, perhaps such a process is quite prominent in creating interstellar rocks. And that's the suggestion that we laid out in this published paper after the analysis of the materials from the Pacific Ocean. And so the idea is that if you have rocky planets like the Earth near the most common stars, dwarf stars, they can be thrown or kicked into an orbit that comes very close to the star by either a very heavy planet like Jupiter in their vicinity that scatters them or creates an instability that kicks them in that direction, or a companion star. And if those circumstances are common, then very often you will get a rocky planet being spaghettified, basically destroyed. And in the process of that happening, the planet comes very close to the star and gets heated to temperatures of thousands of degrees, when at which the rock is melted. And as a result of that, you get the differentiation that I was talking about. So some elements will stay in the outer layer of the planet and others will sink to the iron core. And the outer layer of the planet gets ejected at the highest speed. And I calculated that speed, and it felt like a eureka moment, because the speed that I got from the tidal disruption of a planet like the Earth in the vicinity of a common star, like a dwarf star, like Proxima Centauri, the nearest star to the sun, the speed is 60 kilometers per second, exactly the speed that was derived for this interstellar meteor. So there is a way of making such an object naturally out of a planet like the Earth passing close to a star like Proxima Centauri. But we don't know that to be the case because we found only molten droplets. So hopefully after the next expedition, we'll know for sure what the origin was.